All right, how to draw Lewis structures. Lewis structures represent covalently bonded molecules, and they show, I'm going to change colors here, the valence electrons. These are the same as the group A numbers on the periodic table. So the first family has one valence electron, the second family has two valence electrons, so on and so forth. The electrons are grouped in pairs, and everybody wants to get 8. Which we call an octet. All right, so let's make dot diagrams. Lithium in the first family has one outer shell electron, so we'll put a dot on. Chlorine in the 7th family has 7 outer shell electrons, so we'll put them 2 to a side, and they make a box. Oxygen in the 6th family has 6 outer shell electrons. It doesn't really matter where you put them. Sulfur also in the 6th family. I'm going to make his look different than the oxygens. Boron in the 3rd family has just 3 outer shell electrons. Carbon in the 4th family has 4. Now, when we want to say a Lewis, we're going to draw a Lewis structure. That means we're going to draw out a kind of stick figure of a molecule. The first thing you have to do is count the valence electrons. The second thing you do is figure out what the central atom is. It's usually the first one in a chemical formula, usually the least electronegative. You use one pair of electrons to form a bond between each pair of bound atoms. A line is used for bonds. Each line represents 2 electrons. Sometimes you'll need to use 2 or 3 bonds. And then you arrange the remaining electrons to satisfy the octet rule. Exceptions: hydrogen only needs 2 electrons around it to make it happy. Boron, beryllium can both exist without an octet. Boron can have 6 in his outer shell, and beryllium can have 4. And it's really because of electronegativities. All right, so first thing we're going to do is count electrons. Carbon is in the 4th family, so it has 4 outer shell electrons. Hydrogen has 1. There are 4 of them. So we have a total of 8 electrons. Step 2, the central atom is going to be carbon. We have 8 electrons, and there are 4 hydrogens. Each line is representing 2 electrons. Now, you can also draw it like this. This is not conventional, though, but you can also draw it like that. The beauty of doing it like this is then you can draw circles to show what's being shared. All the hydrogens have 2, which is what they want. The carbon has 8, which is what he wants. But that's much messier, and as I said, it does not follow conventional rules. So we're going to follow conventional rules. Now let's do carbon tetrabromide. Carbon, again, 4 outer shell electrons. Bromine has 7, because he's in the 7th family. 7 times 4 is 28, so when we add them up, we get 32 electrons. Carbon's going to be in the center. He's going to bond to 1 bromine, 2 bromines, 3 bromines, 4 bromines. Remember, each line is 2 electrons, so we have 2, 4, 6, 8 electrons out at this point, and we have to go to 32. So, 8 electrons, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. There's our 32 electrons. We've arranged them. We've filled the rest in. Everybody has 8. If we want to draw a circle around them, each bromine has 8. And the carbon, if we consider each of those lines to be 2 electrons, also has 8. So we fill the octet rule. The next guy, nitrogen, has 5 electrons in his outer shell. He's in the 5th family. Each hydrogen has 1, so we have a total of 8. Nitrogen's going to be in the middle. Nitrogen is actually more electronegative than hydrogen, but hydrogen can't go in the middle. 2, 4, 6 electrons. We have 2 more that have to go somewhere. We have space on the nitrogen, so the extra 2 go in the middle. Okay, and if you want to count, nitrogen has 2, 4, 6, 8, and each hydrogen has 2. This guy here is called a lone pair, right there. He doesn't have anybody to bond with. Boron trifluoride. Boron has 3 outer shell electrons. Each fluorine has 7. So that's 21 plus 4 is 24. Boron's bonded to 3 fluorines. 2, 4, 6. I got to go to 24. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Normally at this point, I would tell you that we would need to make a double bond, and you'll see us do double bonds in a little while. But boron is one of the exceptions. Boron only needs, it can be happy with 6 outer shell electrons. Okay, so boron is breaking the rules. H2O. Each hydrogen has 1, oxygen has 6, so we add up to 8. There's 2, 4, I can't put them around hydrogen, 5, 6, 7, 8. Okay. Ethane, now we're going to have 2 in the middle, 2 carbons. And each carbon can have 4 bonds. Oh, I didn't count. 4 times 2 is 8, plus 6. 8 and 6 is 14. 2, 4, 6, 8, 10, 12, 14. We have all our bonds represented. All our electrons are accounted for. Carbon dioxide, 4 electrons for the carbon and 2 times 6 for the oxygen. So that's 12, 13, 14, 15, 16. 1, 2 electrons, 3, 4 electrons. I have 16. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now we have a problem. Does carbon have 8 around him? He does not. When we don't have enough electrons on the center atom, we have to do what we say double bond. Okay, I'm going to move these 2, and I'm first going to turn them, and I'm going to move them over here, maybe. I'm going to move these 2 and turn them and move them over. Oops. It didn't work, but it's close enough. I'm going to, here, this will be better. There we go. So now let's count. 2, 4, 6, 8. 2, 4, 6, 8. Each carbon has 8. 2, 4, 6, 8. Each oxygen has 8 and the carbon has 8. This is the way you draw your Lewis structure. Do you have to put the electrons at those angles on the oxygens? No, I'm just doing that because I know what it's going to end up looking like. All right, this guy is ethene. Each carbon has 4. Hydrogen has 4. 8, 9, 10, 11, 12 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, if each